In lecture 4, we have learned how to define Python functions using the def method, and how to call the Python functions by typing the function name. And also you learned how to create your own Python modules by writing your functions to a .py file. So in lecture 5, you will learn the NumPy module, which is probably the most important Python module for data analysis and also calculations, and also one-dimensional NumPy arrays, which is going to be a starting basics. And we will also try to make one-dimensional plots with a very powerful visualization module called Matplotlib. So recall the Python lists. For example, how to define a list. So here my list is the name of the list, and remember that we use it as square brackets, and or you can define the list, use the list function. So now this list I have a string, a boolean, a floating number, an integer, and a complex number, right? So lists can have different data types. And remember that you can also do slide indexing like list 2 to 5, and 2's included and 5's excluded. And also we tried building methods such as index, append, remove, and sort. And I think you've tried some of these and you know what they do and how to use them, right? So let's try and define two lists called weight and height of a bunch of your patients. Assume that you're a doctor working with numbers. All right, so how to define list? So I define the list called height, which is basically the height of my patients, right, from 1.73 all the way to 1.79, 5 patients. And also I define another list called weight. That's the weight of my patients in kilograms, right? So now you can type on the bring out to the type of the lists, and so type of height and type of weight, and both of them are lists. And remember that in a Python code, if the last line is not it's not a print function, it will print out the results of the last line. So here it's printing out the types of the two lists, right? So you get an output called list and list. Right. So now if I want to calculate the body mass index of all patients, what should I do? So give you if you don't know what that is, basically it's your weight divided by the power squared power of 2, right? So it's weight divided by height squared, right? So can I do this? So the first thing pops out is that I can do BMI equals to weight divided by height to the power of 2, which is quite straightforward, right? It's natural, like I can do that. But if you try to do this, and Python will tell you it's a type error, right? So this is error message, means that something's wrong with your code. And this is the type error, which is the actual error message, says unsupported operand types for double star or power, list, and int, which means that you cannot use lists by doing operations like that, which is not allowed, right? So remember that what should I do with a list? So you cannot operate Python list as a single variable. So what can I do? Remember that we learned for loops last time, right? So recall the for loops. And here, let's have the weight and height list defined in this way. So remember that what I can do is I can loop through every element of the list, and I do the calculation one by one, and then I append them to a new list, right? So this is what I do. So first of all, I'll define a variable called n equals to len of height. So the len function gives the length of the list, which is assigned to a variable called n, right? So now len height is going to be 5, so n is actually 5, right? So then I defined a empty list called BMI. So BMI equals to square brackets pairs, so that's an empty list. So now this is going to be the main code that does the job, which is a for loop, right? So most of you have worked with for loops, and you should be getting more and more familiar with how for loops works, right? So for I in range n, right? So two things. One is that range n gives me from 0 to n-1. That's a list, a range of numbers, right? So I'm going to step through from 0 to n-1, right? So for first one, I is 0. right? So BMI dot append and something. So I'm trying to append this number to the empty list BMI. So when the first time I equals 0, so I'm calculating weight 0 divided by height 0 square, right? So that's the BMI of my first patient, right? So then move to next one, I is going to become 1, and it becomes weight, the second element calculated by the other, divided by the height square. So by do one by one into I equals to n minus 1, then we are up to the last patient. So I'm doing also the BMI calculation for the last patient and append to the list. So by doing that, when all the steps through is over, and you print out the BMI, which you get 5 numbers, that's the BMI of my 5 patients, right? So what happened in this code is that first, you define a new list called the BMI, right? And then you step through each element in the two lists using a for loop. This is called for I in range n. So I'm stepping through number of elements. And I'm using the list indexing, which is Python indexing. And remember that index starts from 0. So indexing to get access to all the weight and height in each list. And I do the calculation using the BMI equation. And then I append the results to the empty list BMI. So the BMI list keeps growing every time it gets called, right? So it's after when I equals to n minus 1, I've done everything. So I print out the results, right? So this is how you do it. Or there's another way you can do more advanced for loops using the zip function, which is actually very useful, which allows you to step through 2 variables at the same time, right? So take a look at this. So this is my list of height and weight. So I also create an empty list of BMI. So the syntax become for parentheses I, comma, j in zip, weight, and height, which means that Python knows that I'm going to step through 2 lists, right? So I goes through all the elements in weight, and j goes through all the elements in height using the same indexing in this way, right? So every time for ij equals 0, and they're going to be the first pair of data put into this one. So when the first time for the iteration, I equals to 1.73 and j equals to, I equals to 65.4 and j equals to 1.73. And then you calculate the first BMI. And then you step through the next pair, and the third pair, the fourth pair, and the last one, right? So this is the way that you can step through 2 lists at the same time. And you can also do 3, 4, 5 if you want, right? So this is what I did. It's the same idea that you create a new list called BMI, and we step through the elements in 2 lists at the same time with this zip function using this syntax. And also you calculate the BMI for each element and then append the results to the list. And then you generate a new list with the BMIs of all your patients. Okay, so the for loops we just discussed the 2 ways combined with Python lists seems to get the job done easily. Well, sort of. But it's tedious, right? So you need to write for loops for this kind of calculations every time you want to do this kind of straightforward calculations. And it's actually very inefficient. So for some of you might be used in other codes like MATLAB, you know that for loops for this kind of high-level programming languages, they're actually very slow. So it's an interpretive language, it never gets compiled. So for loops are very slow. And there are actually better ways to do it. And that's something we can do easily using NumPy module, right? So NumPy means numerical Python. That's Python for numerical calculations. So let's take a look at the code looks like this, right? So import NumPy as NP. If you remember that this is the way how we import the NumPy module, but the NumPy, 5 letters, that's too many, we change it to NP, right? So first we defined lists, and then we convert the list to NumPy arrays using the dot array method. And by doing that, and then you can do the calculation just a NumPy weight divided by NumPy height square, and then you get the results, right? So if you look at the output here, is that you get the first weight and height, both of them are lists. Their types are list, right? So if we convert the list to NumPy arrays using the dot array method, so np dot array height Remember, NP is the nickname of NumPy module, and .array is a method that belongs to this module, right? So if we type after the conversion, we got NP underscore height, NP underscore weight, and then we can type, bring out the type of the NP underscore weight and NP underscore height, and you can see that what you get is both of them are NumPy ND array. ND array means n-dimensional arrays, right? Here it's one-dimensional, right? So then you do the calculation directly using the way that the weight divided by height, but remember both of them are NumPy arrays, and then you print out the results, and both BMI is also an NP array, and you got the numbers in this way, right? So let's take a more detailed look at this code and try to get you more sense about how to write a code like this, right? So the first of all, we need to import the module NumPy. So this is people usually do is import NumPy as array and give it another nickname called NP, which is easy to use. All right. Then we define two Python lists. Remember, these are lists, right? By square brackets, so both of them are lists, and have the elements are each height and weight of each patient. All right, so remember that we cannot do the calculation directly using the lists, but we can do with NumPy array. So what you need to do is that convert the lists to NumPy arrays. So how to do that? So we make that using the dot array method. So the syntax goes np dot array, and you put the list here. So the output is assigned to a new variable, which is a NumPy array called np underscore height. So does np underscore weight. Right, so after you get these, both of them are NumPy arrays in this way, right? So to calculate the BMI directly for NumPy arrays, and you can do the calculation directly, like one single variable. So BMI is a new NumPy array equals to NP weight divided by NP height square, right? So this is a very simple calculation. So this calculation basically equals to the for loop that we just did. Right, but here for NumPy array, you just need one line of code, right? So that's called element-wise calculations. Then you don't need to write a for loop anymore, right? So how does element-wise operations work? So look at this code. So when we do the calculation here, so the first time the code does is that grabs the elements in the first index, which is 0 here, both of them, and do the calculation 65.4 divided by 1.73 square and get one number, right? So then move on to the next one is grab the same element, the element with the same index, which is the next one, and do the calculation. And you do the third one, you do the fourth one, and the fifth one at the same time. And this is all done by this simple syntax in this way. So we print out BMI in this way, and you get that. So why do we need NumPy arrays? As you have seen from the examples, that NumPy arrays are better solutions to this kind of element-wise calculations for numerical lists. For example, you want to do exactly the same calculation for each element in a bunch of data. So it's better to use a NumPy array rather than stepping through a list using a for loop, right? So for this kind of calculations, NumPy arrays are good for numerical calculations in Python and are alternative to Python lists, and calculations over entire arrays, and really easy to use, and they're extremely fast because they're optimized in a very lower level programming language. So you can work with your NumPy array using the most of the operators we have learned in previous lectures. And Python knows that it's a NumPy array, and it will do all the same calculations for all the elements in the NumPy array, right? For example, if we want to know whether someone's BMI is greater or less than 25, let's say greater than 25. So you simply we do the calculation with BMI greater than 25. Remember, that's a relational operation. See which one is greater than 25. So what Python does is gonna take all the elements in the BMI array. Remember that we have 5 numbers, and we'll compare these 5 floating numbers with 25. If it's true, then if it's greater, then it's true. If it's smaller, then it's false, right? And then you generate a new NumPy array with all the Boolean results and assign the value to another array called fat, right? So if we do this, fat equals to BMI greater than 25. So we print out the type of fat and the results of fat. What you get is that, first of all, fat is type known as NumPy n-dimensional array, which is a NumPy array. And then the results of fat will be false, 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 true, and true, which means that the last two elements in the NumPy array, BMI, has a value greater than 25. So that's very convenient. If we want to know the BMIs that are greater than 25 in the list, and now you can simply do BMI with indexing, right? So now instead of using a numerical indexing, we're actually using an array indexing with 5 booleans, right? So what the code gives you is that if the index is false, it's not going to give you anything. And it only gives you the numbers that with the index is true, right? So in this case, you got 2 values in BMI, which is the last 2, which are the last 2 elements in the array. So you got 2 BMI values, one's 27.8, the other one's 30.8. So these are greater than 25. Otherwise, it's not. If it's false, then you don't get output. So there are more operations for NumPy arrays. These are actually very useful skills. So to specify a condition, you can also make use of logical operators or AND. So you can put things together, right? For example, if you want to see if there's anyone whose weight is greater than 65 and height is less than 1.75, and you can simply use the relational operators and also combine with the logical operators AND or in this case, right? So here's the code that you can do. So we define someone who's has a weight greater than 65 and height less than 1.75. We call that heavy and short, right? So in this way, we do this relational operator, and also we do the logical operator, put them together. Either one is, this is AND. So both of them, if both of them are true, and then you got true, right? So in this case, if you do that and we print out the results, and then you got a new array, tells you that the first element has weight greater than 65 and height less than 1.5. Right. So now the heavy and short consist of the series of booleans, which tells you whether both conditions are met. Right. So now the same idea. If I want to know what's the weight and height of that person has met these two conditions, I just use array indexing with this Boolean index, right? In this way, we do print NP weight with the Boolean index and height with the Boolean index, and we got that the first person has a weight 65.4 and a height 1.73, which is very convenient, right? So this property is very useful in filtering data. So think about this: when you have a big data set and you're trying to take a bunch of data that are useful, because some of the data could be completely wrong and we don't want to use them, and you can use this kind of filtering conditions to define what data I need, what data I don't need, right? For example, here I want to filter out person with this kind of properties, and using the indexing first, using the relational conditions first, and then indexing second, and I pick up the data, right? So this is actually a very useful filtering technique, and then we'll be using in future in both NumPy and Pandas. So there are actually more methods that you can use with the NumPy, because NumPy is a module, right? As we know that there are lots of methods. For example, you can use minimum, maximum, mean, sum, and std, right? So minimum, pay attention to the syntax. So NP weight is my NumPy array. So I dot min parenthesis, that gives me the minimum value. So that's maximum, medium, and you know all this. And dot sum give me the value of summed over everything. And std is a standard deviation, which is a standard statistic quantity in this way, right? So you can get all these results. But the median function is slightly different in this way. So median function, print out the median function this way is that we use the method called np.median, but the input has to be the name of the NumPy array. So np.median, np underscore weight. So you got weight of 65.4. So you can also use other functions like sort, which is also very useful. So you can sort the array in a increase order in this way. So you can do sort BMI, and you can starting from the lowest number to the largest number, and you can also do the other way around. And you can look at the Python manual on the python.org, or just Google, NumPy methods to figure out what you can use for these NumPy arrays. Let's take a look at more basics on arrays and NumPy. So for a one-dimensional NumPy array, for example, the np_height array, if we point it out, it has 5 numbers denoted by square brackets, which is similar to lists. So the idea here is that you, first of all, np_height, that's the name of the NumPy array, and that's the array, and these are the elements in the array. And also for index, it started from 0 to 4 with 5 elements. So one-dimensional NumPy arrays are basic data structure of NumPy module, which contains a series of numerical numbers with indices starting from 0. But not like lists, NumPy arrays can only have one data type. So you cannot have mixed numbers and strings in this way. All right. So index slicing in NumPy arrays are the same as lists. And you can see that if you do the square brackets, and here the first index is inclusive and last index is exclusive. Right? For example, if you want to do np_height 1 to 4, so you get 3 numbers from 1 to 3, but 4 is excluded, right? So you get 3 numbers by doing this index slicing. So another important way that we need to learn is how to create NumPy arrays. So creating NumPy arrays, sometimes people calling these are creating empty arrays that are used to be filled or used as placeholders. Like for example, if you remember the for loop for calculating the BMIs using the lists, when we do the for loop, we always create an empty list, which will be filled later on for the calculated numbers, right? So you do the same thing for NumPy arrays as well. So you can initialize, sometimes it's called initialization. So initialize these NumPy arrays with ones or zeros, but you can also make them filled with evenly spaced values, constants, or even random numbers, right? So here are more ways to create one-dimensional arrays using the following functions, and you don't need to memorize this, but you need to know the way that you can do this, right? For example, create an array all of 1. So np.ones 4. So that gives me array with 4 ones, 1, 2, 3, 4. The second one is create an array of zeros. In this way, I got np.zeros 5, and data type is 6 digits in it. But it's going to be all zeros, so what I got is 5 zeros. So basically zeros 5. So the third one creates an array with 6 elements, but they're all random numbers between 0 and 1. So this is called np.random.random6, which looks a bit bizarre, but this is actually saying the random here function is a function of the submodule called random, which belongs to the NumPy module, right? So you just need to remember the syntax this way. All right, so the next one is we do np.empty7, that creates an empty array, which basically filled with all zeros. And we create a full array with 8 and 7, and then you can do that. You can get a new array with 7 all filled in, but there's 8 numbers, right? And then we can also use the arange function to create evenly spaced values filled with the array, right? So this way, arange function is the same as the range function that we've used to create lists, right? So it's starting from 10, stops at 24. Remember that 25 is excluded, and 1 is actually the delta, increasing, right? So this one, np.arange 10, 25 to 1 gives you 10, 11, 12, all the way to 24, because 25 is excluded. And there's another one that you'll be using later on, and remember there's difference between this arange and linspace. Linspace is actually for linear spacing. right? So linspace does from 0 to 2 and spaced by 9, right? So what here is that they're starting from 0, stop at 2, and I pick 9 points, right? So what you get is that starting from 0, stop at 2, and there are 7 values in the middle, right? So in this way, you get this NumPy array in this way. So pay attention to the difference. This is actually in the arange function, this is a delta. And then in the linspace function, this is how many points you pick between the two ends of the values. So index slicing in NumPy array is the same as what you usually do. For example, let's create a NumPy array called num. So num equals to np.arange 11, 25 to 1. So this is actually creating a list from 11, a NumPy array from 11 to 24 and stepped by 1. And you can see that's from 11 all the way to 24, right? So if you want a second element, that's num1. So that gives you the second element, which is 12. And if you want the last one is num -1, that's give you the last one, which is 24. And you can create a subset from the third one to the 10th, which is going to be 2 to 10, right? So that's the same as what we did in the index slicing for a list. And also you can step through the list creating a subset by every other element in your NumPy array, and you can see that that's how you do it, starting from the third one and stop at the 10, which is excluded, and step by 2. So what you get here is actually 13, 15, 17, 19, and the next one with 21 will be outside this range. All right, so the last one is actually 2 all the way to the end. This is also the same as the list. So pay attention to this index slicing method is that in the list, we didn't do that, is that we have index start, which is inclusive, and index stop, which is exclusive. And then you can have the third number, which is the actual index increasing, which is delta. So the default is 1. So if you don't specify the delta, you're starting from index to start and increasing 1 by 1. But you can specify 2, so it'll be increasing step by 2 by 2 by 2, 4, 6, etc. So you can also load the NumPy module and call built-in functions in NumPy and also constants, which will be something similar as we learned from math. Right? For example, we can use the NumPy module the same as math, which has the pi and square. So we can do that import NumPy. So I'm not changing the names. What I do is I can numpy.pi, which gives me the value of pi, and the same numpy.sqrt, which is square root of 9, that gives me 3. Right? So pi and sqrt function, these are also functions in math, in the math module, which is another module of Python. So you can also do the same thing as NumPy, import NumPy as np, and now I just change the module name to be np and everything else the same. So remember, the most lazy way will be import from NumPy import star, which means that import everything. I am giving up the module name. I'm just using the function names. So you can now access the pi, sqrt, and sine in this way, right? So now you can see that why we need either this way or that way for the modules, because now it's confusing because I have pi from both NumPy and the math module, and also have sqrt function from both NumPy and math module, right? So it's confusing that which one are you using, right? This is an easy example because these pi is going to be the same for everybody. But when you're doing more complicated programs, codes, projects, and you might be having the same function name but does completely different things, so that will mess everything up. So better to use import method either this way or that way. So this is a list of NumPy functions, which is not inclusive, but these are functions that we use a lot, including the basic functions and sine, cosine, all everything, exponential, logarithm, and also these round functions, and also other mathematical functions that you can take a look at. And you don't need to memorize these functions, but just give you a sense that NumPy is a module that does numerical calculations. So basically, basic or slightly basic calculations with fundamental functions that you can all find in a NumPy array. And then you can go take a look at the NumPy manual, which is online and very lots of details, and you can find all these functions are there. Before we start to look at visualization, let's first try to create a new NumPy array using the arange function. All right, so look at this code. So I'm using the arange function to create a NumPy array list of angles that from 0 to 359 and at 2-degree intervals. So this is np.arange 0, 362. So 0 is included, 360 is excluded, and step by 2, right? So now next I'm converting these degrees to radians, right? So if you're not familiar with radians, the difference is basically degrees times pi divided by 180, right? So basically converting from 0 to 360 degrees, or almost 360 degrees, to 0 to 2 pi. So the next I'm using the sine function to convert all the degrees, all the theta in radians to be the sine of all the thetas. Remember that this is the element-wise calculation. So theta here is a NumPy array with 180 numbers, and sine theta, which calls the sine function and calculate the sine of each theta. So now I got, after the calculation, I got another NumPy array called sine theta that has the same size as the theta in radians, but it's a sine of each theta. Then I'm printing it out. So you get the list of arrays this way. The sine theta is a new array with all these numbers of the sine. So to get a sense of what your array look like, and you can use the following functions. These are very useful functions, and pay attention to these. The first one is ndim, which is a number of dimensions, and ndim theta in degrees, and it gives you 1, which tells you that a theta in degrees, this NumPy array is a one-dimensional NumPy array. And the other one is size. So size, theta in degrees, it tells you how many elements in your array in total. So what you get is 180, right? From 0 to 360, step by 2, so that's 180. So the third one is shape, which tells you the length of the array in each dimension, right? So what you get shape, theta in degree, as you get very weird output with started with parentheses. So 180 comma and then nothing, which means that it's a one-dimensional array, has the first dimension has 180. If it's two-dimensional array, and you get 2 numbers, and three-dimensional, you get 3 numbers, and so on and so forth. All right, so now we've done calculating the sines of theta and typed in sine theta, and this is what we get, right? So we define theta, we convert theta to radians, and we calculate sine theta, and we output sine theta in degrees, right? Sine theta in what? In this way, and you can see that we have a list of numbers. And what do I get, right? So what's the problem here? The problem here is that nobody, at least not me, has any idea about what those numbers mean, right? Because these are just a bunch of numbers, and human eyes are just not sensible to such a list of numbers. For me, it's just a headache, right? So here's why we need a visualization. And let's try to make some plots using another Python module called matplotlib. And this is actually another module, a module that will be used throughout the course, and you need to get used to how to use matplotlib. So the easiest way to do this is using the package of matplotlib, which has many plotting functions. And the one that we will use most will be called the pyplot. So to import this module, and we use this syntax, import matplotlib.pyplot as plt. So just remember that when you're trying to make plots, and we use this way to import the results, and just copy and paste that to your own code. So we import the module and call it plt, and then we do plt.plot theta in radians and sines, and then plt.show, and what I get is a nice box with the sine curve in this way, starting from 0 to 100 to 360. in this way, right? So let's take a look at the code. So first of all, import pyplot from matplotlib. So this is syntax: import matplotlib.pyplot as plt. So what happened here is the matplotlib is the name of the whole package, and pyplot is one module from the package, and plt is the nickname we give it, right? So we import pyplot from matplotlib and we name it as plt. So the second one, we use the plot function, which is dot plot. And remember that plot is a function from the module plt. So you need to dot plot, and then with two inputs, theta and sine theta, in this way, right? So plt dot plot theta and sine theta, and with other options. And now the next one is actually the plt dot show, because in lots of cases that if you don't have this plt dot show function, you will generate a plot, but Python will not show you, right? So this is tells you Python, like, show me immediately what the plot look like. So when you do the plots, right after plot and do a plt.show, right? So what does this function do is that the plot is the name of the function. So plt is the name of pyplot, which is a library, a module, and plot is the name of the function. So the first input is x here, which is the horizontal x, and the second x is the vertical axis. So now you can see, let's take a look at this plot.theta in degrees. So what I do here is theta in degrees. Remember, that's my NumPy array from 0 to 360 degrees, right? So it's from 0 to 360 degrees. So that's theta in degree, which is the horizontal axis. So y is actually the sine of all those values, and we saved that values in the array called sines, right? So sines from -1 to 1. So by doing this, and I'm plotting sine theta as a function as theta. So this is plot x and y does. And there are options, and you can specify the style of your plot. For example, color of your lines, the width of your lines, and the markers, and the axis and limits and everything, and we will go through that. We will try to do that in the next lecture. All right, so you can also put NumPy array operations within a plot function. For example, look at this code. So we import NumPy as NP, and we also import pyplot as PLT. And now we create a theta function array, use the arange function, from 0 to 360 degrees stepped up by 1. So this 1, 2, 0, 1, 2, 3, 4, all the way to 359, right? So now I'm making a plot. So remember, this is the x, which is the horizontal axis, is the theta, from 0 to 360. And then the y is, instead of using a y, I'm actually replacing y with an operation, right? So this operation here is basically doing theta, cosine theta to the power of 2.5, right? So before I do that, I convert theta from degree to radians, dig to rad. So that's converting theta from 0 to 360 to 0, or 0 to 2 pi. So this is plotting cosine theta to the 2.5, right? And then you show the function.